Okay, in today's class, we would learn process specifications. So, what are the works? What are the jobs? If one bubble, we will take one bubble. Which kind of jobs it will be performed? Okay, those are the specifications of that particular bubble or this process unit. Okay, so here this circle symbol is called a process symbol. Okay, this circle symbol is also called as a bubble. Okay, this bubble has many activities. So what are the activities which is going to perform in a project? We'll see now. First one is it's a narrative. So whatever the things it will take as input. Okay, it will describe about that one. Okay, what it is and how it is going to work, what we have to do with this. Okay, we are going to store the information or not, or we need to describe that in some other manner or not, like that. Okay, it will narrate the given input. And pseudocode. So pseudocode is a one kind of coding. I think it's a second generation language coding. So whenever we are sending the instructions in high level language, if there is a need to transfer those thing into a pseudocode or not, if it is necessary, it will convert into a okay second generation language. Okay, first generation language is a binary language. Second generation language, the assembly language is used by assembly language, which means uh, that is called a pseudocode language. Okay, which means it has some mnemonics to understand, right? That is a one kind of language here. Or this process may have equations. If it is having some equations, okay, we will calculate those equations and we'll send the, I mean, we'll give the result accordingly. If we have the tables kind of data, so what should we perform? Any filtrations do we need to apply on that particular data? Okay, filtering means suppose if we want to get only some column data or some few records from that particular table. So like that, if we apply some filtering things, okay, then so that kind of things we will get. Or otherwise, if you want to create any kind of tables information, whatever the generated information here from sensors or something, it will be formed as a tables. It will be formed as a tables. In every language, in every application, you may see the text form or some application form, it will be in user view, but in at the end or background, it will be saved, everything will be saved as a table. Okay, that every application, maximum number of applications will be attached to a database. That if the database is okay, is like a oracle, which means it is like in the form of tables or dbms kind of tables, then the total data, whatever we are entering through that front page, okay, from user panel, that will be saved in background, okay, as tables, right? And diagrams, do you need any kind of diagrams to process? So this is about the specifications. Okay, specification works of a process here. If we'll see that, this is already we have seen that. Okay, and the next slide is control flow modeling. What is this control flow modeling here? Till now we have discussed about one word, data flow. Data flow. In data flow, we are talking about, or we are thinking about, how the data is transferred from one bubble to another bubble. Okay, till now we have think, or we have spoken about only the flow of data, the flow of data uh, in between. Okay, see, this is the one flow of data, and second flow is from here to. Here this is one flow of data, and if you go take the third flow, okay, this is third flow. So like this there are different ways, the different ways, okay, to fulfill the different tasks are there to fulfill. Okay, so based on that here we are discussing about data flow. But what is the control flow here? Now we are going to discuss about 545. Who is that? Right. So till now we have discussed about only data flow. Now we are going to discuss about a control flow. Okay. So control flow in the sense, yeah, I understood. Right. Control flow modeling in the sense it represents the events. It represents the events and the process that manage the events. Control in the sense it is going to control the flow of a data wherever it needs, wherever you want to stop, wherever you want to deviate the working nature of something, then you mandatorily use control flow modeling. Okay, this control flow have some events and also some process that manage the events whichever we have. What is an event here? An event is a boolean condition. Boolean event is depend upon some boolean condition. Okay, if if something is yes, do this one. If something is no, do that one. Okay. Naturally, we are writing some if conditions on C language. How are we writing? If the given value is, if the given value is divided by 2 and it will give the result of remainder value of 0, then print the given number is even number. Otherwise, print the given number is odd number. Okay, boolean means true or false. If it is true, what we have to do? If it is false, okay, then what is the what the things we have to do there? So like that, here we are going to check. So what we have, what is the condition of that one? The given number, which means n equal to 20. N equal to 20. So within the if, what we are going to write? If n modulus or n divided by 20, n modulus 2 double equal to 0, that is our condition. If that remainder value will be the 0, so automatically what it is doing, it is going to print the given number is even. Or instead of having that particular statement within that within that true condition, you may write anything whatever you want, which kind of operation it needs to done, that is your choice, programmer choice, isn't it? So here also, so when we need at that place we put some controls or conditions based working nature, controls or condition based working nature. Through that only, okay, we can meet some works. Okay, if yes, we have what we have to do, if no, what we have to do now. Okay, today 4 o'clock, if SE class is there, we should attend for that SE class. Otherwise, we'll go and watch the movie, or will go for some time sleeping, or otherwise going to read the subjects for preparing for examination. So different multiple tasks you have, not only one. If no means you have multiple options, but if but it is yes, only one option. Huh? You need to listen my class, right? So like that. So here we are putting some conditions on the works. So which kind of things will occur? Which kind of things will occur? Listening all sensors that read by the software. If you have sensor devices, okay, input reading devices, you should take each and every sensor's information. If suppose if you are attaching five cameras to a TV or your computer. Okay, it's all five cameras are monitoring each and everything where you have fixed those cameras. If one thing is not working, it's because of some technical problem. It is okay off. So how would you know about that? By setting some instructions. By setting some instructions. If something is happened, okay, apart from a regular thing, automatically, okay, it will give some indications or instructions to the owner, isn't it? Yes or no? So like that, what we have to do, if something is going on in regular way, it's okay. There is no need of worry for any other things. If it is not, so what is the action should take place at that time? Already, I think you are learning Java now. No, I think only you are learning. Oops. Okay. Uh, I think you don't have Java concept. Okay. This is one kind of alerting systems. Alerting systems. Events in the sense, if something is not in a regular way, then just alerting the customer. Why are you using the alarms? If you want to wake up early, okay, then obviously we'll use some alarms. We'll set for alarm for some time, 5 o'clock, 4 o'clock, 3 o'clock, like that. Whenever the clock is reached at that time, automatically, okay, we'll get some alarm sound from our phones or clocks. How it happens? Already we have set or fixed time, and we switched on that particular action button. Okay, so because of that, whenever it will be reached at that point of time, then automatically we'll get some alarm sound. Clear? That is one event. That is one event here, that alarm sound, okay, is event. Okay, that is the result for whatever we have expecting, like that. Whoever set that alarm, us only, we only. Okay, we only just set that alarm for 5 o'clock, 4 o'clock, 3 o'clock, like that. Then we'll switch on that particular, enable that button, and we'll after automatically after that we'll forgot will be forgotten also. It will remind us, isn't it? So the type of things is called the events. Sometimes it may be a interrupts. Interrupt conditions is also called a event. Okay, now I am teaching the class. So I got one interrupt, isn't it? The interruption in the sense something is happened. If now I'm moving one flow, to break that flow, if something is happened in between, that is called interruption. That may be for good sign or that may be for bad sign, that is different. Okay, but something interruption has occurred with a particular point of time, right? So that is also called one event here. and listening all the switches, whether all the switches are working or in activation scene in activated condition or not. If anything is wrong, automatically just it will give some instructions. Even though we are fixing some what uh, uh, things in our homes, if something fire will come means automatically alarm will be activated. Okay, many houses will be used that things. Okay, based on that fire engines will come to stop firing, right? That is also one kind of event, control event, right? Listening all data conditions, whatever the data here we are using within that particular function. So it is following all the data, whether these people are entering correct data or not. If the credentials is wrong, automatically we will get one what uh, instruction. What is that? Your credential, your entered credentials is wrong. Okay, that is also a one event. If it is right, no worries. If it is wrong, it will warn us. And it may have how many number of times would we warn that particular user or customer, that will also be stored. Okay, in inbuilt, stored into our program inbuilt. That is based on a developer interest. 2 times, 3 times, 5 times, 10 times also it will allow sometimes. Okay, like that. And also, okay, it will review the all the control items whatever we have used within that particular project. Okay, it will be controlled everything, which means it will monitor everything related to that particular project. If something went wrong, automatically, okay, it will warn us. Otherwise, okay, everything would be clear here. Okay, so next we have control specification. Till now we have, in previous slide we have seen process specifications. Okay, now control specifications. C spec, spec in the sense specification, C in the sense control. Previously we have one PSEC, PSEC in the sense process specifications. Okay, don't worry about this abbreviation, it's nothing, it's a normal word. Okay, specification. So these control specifications may have state diagrams, okay, state transition tables, or decision tables, activation tables. Okay, if something went wrong, so immediately we have allotted some other work to that particular what concept or project, it seems. Okay, what are the controversy to that particular work? So those things we should be mentioned in different ways. Anyone, I mean different ways, types. If one user entered a phone password is wrong, how many times it will ask us? 2 times or 3 times or 4 times or 10 times? After the 10th time also the password is wrong, okay, automatically the flow phone is blocked, isn't it? Even though in movie of Shivaji also the same situation happened, almost in climax scene. What some villains are trying to open the laptop of the hero, then it will be allowed first time or second time, okay, for some codes. After that automatically the total data will be erased from that particular laptop because of wrong credentials, because of wrong credentials. Who said that one? The hero, okay, was set like that. If something went wrong, okay, delete the total data, whatever the system has, or or confidential data, delete the confidential data, something. So even the firewalls also will work in same manner. Have you listened that firewall concept? In that firewall concept also the same. If something went wrong, okay, so what is the further actions it should be taken? Also, we are mentioning within that particular program or process. That's why even though in C language also we are going to use else condition. Why we are using the else condition? Okay, always the thing, the statements are not always true. Sometimes it may be a false. Okay, because of human errors, because of technical errors or something, anything. It may be wrong. What is the next step? What is the decision we have to take there? What we have to do? If it is true, execute this block of statement. If it is false, just come out from that program, complete program. Or if it is false, go and execute some other block of statement, block two statements. Like that, we are instructing the program. We are writing the program. Here also same. If something is executed, okay, in one manner by following one approach, the work is going on smoothly. Okay, if somewhere at the some part of that particular work, okay, would went wrong, so what is the step to take, okay, related to that wrong credentials? Okay, whether we will give the chance to that particular customer or no need to give chance to that customer, and we are going to take some any other actions or not further, right? So for that here we are having some control specifications. The control specification should be drawn or should be implemented by using state diagrams, or you may take state transition tables, or you may take decision tables, or you may take activation tables here. All right. And if you'll see the next slide, here we are having behavioral modeling. Till now we have seen some control specification. So with this control, with this what control flow modeling, in control flow modeling, first we have seen control specifications. Now we are going to discuss about behaviors. Okay, then we are going to see some state representations, now state diagrams, right? So in behavioral modeling, first the behavioral model indicates how software will respond to the external events or stimuli. If I am the external event, which means if I am the customer, how my software will respond to me, or otherwise how ATM will respond to me, how library management will respond to me, or otherwise how what in restaurant some people serving people are there, how they are responded to me. Okay, if I am a external event, so that is called behavior. What is that? That is called here behavior. Behavior is a representation of response, okay, to the external event from our developed software or system. Okay, if we design one ATM, if we design or developed one ATM, how it is responds to a customer. If the customer entered a wrong pin, okay, the customer entered a wrong pin, how it is responded to him. Okay, if the customer is not entering any pin, just he inserted card and just simply stand and watching that ATM. So how it will be respond? How it will be respond in such a cases? Okay, otherwise, otherwise, okay, he performed one action, one transaction, that is withdrawal. Okay, withdrawal. After that, okay, he has taken some amount from that ATM. Then that ATM machine would ask one question, whether you need a printed receipt or not, like that. So the customer will be stand ideal. So what happens? What is the next step it has to take? Okay, until unless the ATM card is released from that particular ATM or not. If he doesn't choose any option from that, okay, he doesn't choose whether he needs that particular printed slip or not, then what is the next step there? So like that, what is the behavior of a system towards a customer situation or customer demand and customer interest, right? um, and even the same, if we'll go to some restaurant, their waiters are there. So how they will respond to us, how they are giving reply to us. Okay, if I ordered something food, if it is not available, so how they are responding to us? Sir, this kind of dish is not available right now in our restaurant. Okay, please be choose another from your menu, from the menu card, sir, like that they'll respond us. If the selected dish is not available in that particular restaurant, how they will respond to us? If they'll speak with us in polite way, in polite manner, we may go for some other options, we may choose for some other options. If their behavior is rude, if their behavior is rude, okay, what, how we are going to respond? So that is the situation here. That is about a behavior, behavior of a developed module or project towards the customer, right? And to create the model, the analyst must perform the following step. If okay, if we want to create behavioral modeling, so what we have to do here? Evaluate all use cases. First, you should evaluate all use cases, which means in use case diagram, we should represent the users, actors, as well as system. And what are the tasks? Okay, would request by an actor, we will represent within that use case diagram. Okay, that's why if you want to build behavioral modeling, then you should first of all you should evaluate the all the use cases whatever you have within that project to fully understand the sequence of interactions within the system. If you want to understand 100% about the project, then first of all you should read all the use cases, then only we will get one knowledge, okay, on that particular work or project. So based on that project, okay, what are the actor roles, how the actor is involving with our system or using our system, or which kind of services he needs from our system, those things can be considered into this project. Then you are going to, okay, design or define the behavioral modelings here, behavioral modeling here. So like that. Next one, identify events that drive the interaction sequence and understand how these events related to specific object. Okay, with one object we may have different actions or different events, how those events are represent related to a one object. Next, a create a sequence for each use case. Okay, how many number of use cases we have? We should create some sequence. This is first, this is second, this is third. If we have 10 use cases for a single project, Then put in order those 10 use case diagrams. Suppose if we draw 10 use case diagram for a single project. So first of all, you should put the numbers for that one. Which one is first, which one is second. Then only we would produce proper output. If those are mismatched means we may get correct output. Clear? So that's why create a sequence for each use case and build state diagram for the system. If you want to, okay, represent the behavior modeling, that should be possible by using a state diagrams. Okay, what we need here? State diagrams. State diagrams are used to represent the behavioral modeling, right? And review the behavioral model to verify accuracy and consistency, whether this is working for this behave, I mean this is working with accurate results or not, the total data is available or not, like that we may check. So that's why now we are going to learn about a state diagrams. Why? Because behavioral modeling is implemented by using state diagrams here, right? um, so we'll see the state diagrams and representations in next class. Now I'm going to stop the today's class.